Welcome to the channel. Today we're going to see something called Hello World of Deep Learning or Computer Vision. And let me give a simple introduction. Before everything we know, we have a misconception at one point of time that a machine can't see the things around it or give us a perspective of how things are going on. And that is something that can be solved using neural networks. And MNIST is one of the golden standard that has been set, and it is one of the simplest examples to understand how machine learning works, how pattern recognition works. It's basically the foundation everyone needs to learn or everybody needs to understand at one point. Now, let me give a quick intro. There is a database of handwritten digits. Basically, they aren't generated through a computer or through an algorithm. They are handwritten digits, which can be of varying shapes. If let's consider the machine only understands the pixels, that means the individual blocks that make these up, and each of them will have varying pixel weights. And for us, the values will be between 0 and 1, and if it is 0, the whole thing is just dark or completely gray. And MNSTI has 60,000 examples for training and 10,000 for testing. We basically train the model with a different set of examples and test the model with another set of examples the model haven't seen yet, so that we can find whether the model gives out the outputs based on the patterns that it recognized, instead of doing the guessing game like we do. Basically, MNIST handwritten dataset and is the one that we use to understand how machine learning went through different phases. And this is something called grayscale, and it is just for info. 0 is for black, 50 is for dark gray, 128 gray, 200 light gray, yada yada yada. And let me show you how this thing is divided into. It is basically 28 into 28. That means 28 rows and 28 columns, and that sums up to this. Where is this one? Yeah, 784. And what we do is we take these in the first layer. After that, we add some hidden layers. That means in these layers we'll find some patterns, and we further reduce them. Basically, we want to fit them into a single output. And we know that numbers, that means single digit numbers, are between 0 to 9. That will be 10 output layers in the end. That means each number will have a pattern and a neuron related to it. Basically, that's the thing. And PyTorch allows us to download this directly, and you can go to the document section and find the datasets you want to download and use them for training. All that I choose the collab notebook for explaining this thing instead of the neat code problems we have in this series. And these three on the top, before the digit classifier, I'll explain them in a separate video. The training diagnostic and diagnostics and dead value detector, these two are quite interrelated. Those are diagnostic terms Here we can find something like vanishing gradient, all that stuff. You can skip the training loop if you have understood all the others on the top. Now let's come to the collab notebook. I want to quickly go through the stuff instead of explaining each and everything that is there. Here I do the import of torch.neural network. This is for neural network operations. Optim, it is for optimization. And if you don't know what optimizers are, check out my last video. And here it is for torch vision. This is for getting the data sets and performing transforms. And this is for data loader. Basically it loads data for our ml model, test data set or whatever it is. And we have a plot library to show the outputs so that it is visually feasible. And this is CUDA. Basically it switches between CPU and GPU whenever we want it. Here I'm using my GPU T4. And basically in the first step we do the normalization so that the weights are predictable and never don't reach 0 or 1 whenever they find it good. So this is the transform. Basically we make the whole stuff into tensors, and after that we normalize the layers. And let's check this MNIST dataset. Basically you need to use the download true and train true for a train dataset. And a test dataset you don't need it for training, so it's false. And download is true. Basically you get the training and testing datasets from this datasets, and we load them in memory. We use the batch size 64. And for training we want them to be randomized, so we shuffle them to true. And basically if we try to visualize the samples, they look like this. The 0, 6, 9, 6, everything looks a little different. Basically how the neural network does this stuff is, let's say you have a 0 here, we can divide this into this pattern like this. Or let's say we have a 4 here, we can divide this into the patterns like this. In each and every layer we do the activation of each of the weights so that they correspond to the pixel pattern. And arrive at this point, we do the optimization and stuff, compare the loss between pixels of the original one and this. So basically it is a set of operations that are being done mathematically. You don't need to go through all of them and understand each and everything. That is quite impossible, if I say. Basically what neural networks does is they divide stuff, find the patterns, then keep the patterns in memory, and update the weights that correspond to these patterns instead of hard coding stuff or overfitting stuff or memorizing stuff. Basically it's pattern recognition in the end. And we start with 784. And we go for the second layer will take 128, and after that it is 64, and after that it is 10. This 10 is inevitable, that I have already explained, because the digits are between 0 to 9. These layers can be decided according to the cost, the time that is needed, and the patterns and the data. Basically hidden layers are something you can decide. And we went with the standard stuff that is there in the internet, 128 and 64. Here I define the class, I initialize the layers. These are linear layers, that means the linear stuff we do, the wx plus b. And we flatten the x so that we'll have everything in one dimensional. And we apply relu for one layer and the other layer, fc1 and 2. fc3 is the hidden layer. Now we just add the model to the device and print out the model that we have defined. We call that whole model class as MNIST.MNIST net. Net is basically neural network, and this is the model. We don't know how it will react, and it is a basic one, and it won't produce outputs that we need because it is not trained. Everything will be linear, like 0 and 1. That's the end values we get. And we define the criterion, that means the cross entropy loss. Here, running this won't do anything because we these are like functions that we derive to make things work. And Adam is our optimizer that we use to update the gradient descent. And here is the training loop epochs. I'm going to train it for 5 epochs. That means five loops in the all layers. And we take the running loss as 0. We start the model training here. And once the training is started, we'll take the images and labels. We apply the optimizer. We use the images and feed it to the model. After that, we find the cross entropy loss between the outputs and the labels. Labels are basically the values we have, the true values. And after that, we do back propagation. That means every step that is done till now will be repeated again and again, these 3 steps. And after that, we do the optimizer dot step. That means we apply the optimizer and add some values to the weights, and we calculate the running loss for this of the item of the loss we got. After training this for 5 epochs, going through each and every image, we calculate the average loss. That means the running loss and the length of the train loader. We append the losses of each and print it out for each and every epoch. Basically, these are still in the epoch, so the output will show how much average loss we got for each epoch. And after that, we'll evaluate the model. For this, we don't need the gradient descent, so it is no grad. And we'll take the images and labels just like we did for training, but we don't do any optimizers or stuff here. We just need the outputs. So we feed the model with to the outputs and find the max of each. And after that, we'll do the metrics accuracy. Um, all that stuff we have already seen in the last few videos about the metrics that are there: accuracy, F1 score, precision, all that. Now we calculate the accuracy here in the end, taking the total of the labels at size 0. And let's run this. Basically, the accuracy is pretty low here, but this is the point of training it. If we increase the epochs and up, tweak the learning rates a little, all that can work out. Now let's do the single prediction here. It will be wrong because we haven't really extensively trained this. The actual value is 7, but the predicted value is 9. But one thing to consider, this can look a little like 9, but the model is, the model confused it with the 9, and it is missing a curve here. Yeah, if we train it for a while and adjust the inputs and outputs for a while, we'll arrive at a good accuracy. And this is the stuff like how the training loss is there, all that. Nothing much to see in this plot thing. Basically, this is the MNIST classification. And as you know, this is a classification task. There are two things that someone needs to know. That is a classification thing. That means you see something and you need to find what it is. That is classification. And the other thing is regression. That means you find something that is in the future, you give out a value. That is regression. Basically, there is a result for regression, and for classification, it is identification, not like a mathematical result or something. As always, thanks for watching. Please share, like, and subscribe. This is the MNIST thing that everybody needs to know at one point in their life. I mean, at one point in their life, if they are doing machine learning, this is called Hello World of Computer Vision for a reason. As always, pretty much this is the thing. I'll add the Polar Notebook in the description and the article I have seen. I mean, the research paper I have seen in the description too. Thank you for watching. Please stay tuned for the next videos.